Okay, for people joining this live stream, this is a language completeness and consistency meeting about Wolfram language with a variety of topics. Okay, what is this first piece? This is
just knitting. So, right, we've added these, I guess, 4 symbols and sort of tweaked one of them. And so,
isn't 12.2, isn't the 12.2 on the 12.2 builds crashing all the time these days?
The latest one, if you have the latest one, which is from like around 11 a.m., that one should be fixed. In fact, I believe yes, in fact, I've downloaded and verified that that one is fixed. But I will need to check what the build number is.
Yeah, it looks like it was from 1505 it worked. Or at least the build didn't fail. I don't know if it still has the crashing problem, but the build succeeded.
It seemed to have lost cloud credentials. Somebody should report that it lost cloud credentials. Could you do that, Devin, please?
Yeah, I got it.
Let's see whether it crashes. Splat.
Okay, Splat. So the latest build of Mathematica is what I checked, and that one works. Assuming it is the one from late this morning.
Okay, so let me just send mail to Roger. Okay, anyway, I should be able to look at it here.
Yeah.
All right.
So, yeah, so basically for these guys, I added one in sort of what I considered the main page, and then I asked Ian to make sort of tentative additions on some other pages, which sort of glanced at but haven't seriously reviewed. So, don't freak out if the tentative ones are not perfect. They're
Okay, so this is let me say okay, so this is options pattern. I would argue that we should put arguments options, split an expression, split a function, right? I mean,
well, it's not the function itself, right? It's a function call.
What does it return? Does it return a list?
By default, yes. I mean, that's customized. Well, it always returns a list, which can either be a list of lists or a list of 2 things with other heads.
Why don't we say split out the positional arguments and options in an expression?
Works
maybe
for me.
Split apart.
Say again?
Or maybe split apart. Split out.
I agree. That sounds better.
Yeah. Okay. Okay, so this would be verify option names and number of arguments in a function. I think we should just say in a function.
Well, then the one below should say function as well.
Right. It's weird that those both basically take the same inputs.
All right. Okay. Verify option names and number of arguments in an expression. For some reason, I think it's easier if we say it the other way around, if we put this one first. Get the options for a function. All right, I'm good with this. Okay. Let's go to, oh boy, this is such an inefficient system here. Error handling.
Oh, that one's still featureized. I guess I missed that the first time around.
Terminate the evaluation of a function. What is all this stuff? Throw failure, catch failure. What is all this?
Yeah, I'm not. Is that what Christopher is working on, or is that no? Those are okay.
This
So
is general utilities, I think. This is general utilities, I think.
Okay.
The throw failure, catch failure.
So yeah, let's just ignore this one then. It's featureized in any way.
Messages. Does check arguments generate messages for incorrect?
Yes, that is its purpose in life.
Okay. Messages for functions.
For functions called with incorrect argument counts.
Well, it's going to be too long. For functions with incorrect argument counts. Generate messages for functions we're not supposed to let it wrap a line. Generate messages for functions.
Would it be too simple to just say with incorrect arguments at this stage?
Right. I mean, on this particular page, I don't know that we really need to distinguish between them.
Fine.
Oh, yeah. Well, this also works. I like this. And well, oh yeah, but this. Well, incorrect arguments. It's a bit.
Okay, with incorrect argument, generate messages. Why don't we just say check
Argument counts and option names and issue messages?
issue messages. We did it.
Okay.
Package bulletproofing, package development. Look, that's going to have a lot of stuff from Christopher's new framework on it. I'm not sure we should deal with this right now. Let's deal with this when we knit. Let's remember to deal with this when we knit, confirm, and enclose.
Okay, so they'll. I mean, like I said, I haven't reviewed it in detail. I just sort of glanced at. Ian didn't do anything crazy, but it's there and, you know, tentatively. Okay. So.
$random generator state.
Right. So that's two symbols, that random generator state and $. But. And so obviously random number generation.
Well, did these things get the right cross-linking in terms of see alsos and so on?
I think so. I mean, if you want to double check, this is why.
No. I mean, the check arguments. Did it get the right see also stuff?
I think so. I mean, we certainly thought about it.
Did I do it? Or
you did not do it.
Okay, but
you know, if you want to quickly review it, let's quickly review it. Right?
No, I think it's probably fine. You did it though, Itai.
I did it.
Okay, fine. I mean, just to poke at some things for check arguments. I wonder if length points at check arguments. Does it?
It does not. It
Seems
It's
sensible.
not okay. It's not super obvious to me, but well, although I guess if you have an argument
how would
with,
you check it?
well, right, you need to split out the right. You need to separate out the options, which is potentially ambiguous. But yes, for an argument without options, then yes, checking the argument count is the same thing as checking its length.
Okay.
For an argument with options, it's significantly more complicated.
Right. Okay. Arguments, options. Where else should we be pointing those? Let's also point those. Wonder what we reference here. I think we should put it in here as well. It's like finding rules, if you understand what I'm saying.
Mm-hmm.
Arguments, options, right?
Yep. Polynomial reduce. That seems like a kind of. Did I read that correctly?
You read that correctly. It's right. It's right.
Oh.
It's not crazy. It's not crazy. Okay. Random generator state, symbolic representation. What? That's an option, right? Random generator.
No. Random generator is a head. Or state is a head.
Oh, I see. Symbolic random number generator. Okay. Why don't we just say the state?
Okay.
Okay, I'm good with those. Tuning and debugging. There's got to be a more efficient way to do what I'm doing here. Okay, hold on.
So somewhere there's a section on controlling randomness, and I think I just added it as a, yeah.
Fine. Fine. Okay, value queue.
Right. And well, here there are 2 points. I added it to one page, and the description on symbol handling is a bit interesting given our conversation from last time. So we might want to take a look at that.
Oh, for goodness frigging sake. Why does it do that? It's really dumb. Okay, what does it say here? Where is it?
On the third section, first item. Test whether a symbol has any type of value. So last time you decided that we should default to only checking own values. So maybe, so I'm not sure what any type of value means. Should we be checking for all the other kinds of values, or should that?
Yeah, possible values for the option method.
Right. And so the default one right now, the default is automatic. Is automatic.
Okay, all right. Test whether a symbol has a value. Should be considered to have a value. Can be considered to have a value. I mean, that indicates that it's a little bit complicated.
Right.
Should it be test an expression rather than test a symbol?
Except that's on the symbol handling guide page.
Oh.
So,
All right,
Yep.
let's move on.
and just want to double check if you want to double check assignments. It's
It's on that page.
yeah. It's at the bottom with information and right. So there's information, and then I added it to the little bullet things beneath, which it seemed to fit in with those other guys.
It's okay.
Yeah.
Okay. All right. Let's talk about this cleanly.
Right. So, I like it. It's here to see if people have
All right. So the
other opinions.
init expa
Cleanup.
start expa end.
Yep.
I mean, what are our alternative names?
We talked about with cleanup or just cleanup or something like that. Although I think cleanly is probably a bit better than those, but
Yeah. I mean,
or just clean. Yeah.
Clean, evaluate. Clean. I think clean is wrong because it suggests it's cleaning what it contains.
right.
Evaluate, clean, evaluate. Well, that really helps.
I think clean evaluate is better than evaluate clean. I mean, you could go with evaluate cleanly, although at that point, why don't we just call it cleanly?
Yeah, why don't we just call it clean?
Right.
Let's
Most
write an
things
example.
evaluate.
Yeah, why don't we just do an example? And by the way, do we have any page for this or not yet?
We do not, I don't think.
Let's
Unless
try and-
Christopher created one.
I haven't.
Yeah.
No.
All right, let's try and create one. Oops, 12.2.
Maybe someone has made a page about with local settings, but I'm not sure.
Not as far as I know.
Okay, so we say here, okay, cleanly. I'm just trying to write the words to see whether we can make it work. Okay, so this says, init, does it have a 2-argument form or not?
Would that be without a knit or without cleanup?
I think without a knit. It does
Yeah.
I mean, if it's without cleanup, it is just compound expression, right? So
Right. I mean,
Right.
the other possibility, I mean, one possibility is we restructure it so it's always 2-argument, and it can be either a tuple or a single argument in the.
Nah.
You
By
know,
the way,
like-
Ethan is commenting that under languages, cleanly is called fixture. Really? What on earth? Why on earth would it be called that?
I'm not an expert, but I have not heard that terminology before.
Christopher, have you heard that?
wait, in what context is it called fixture?
Ethan is saying other languages cleanly is called fixture. I've never heard that.
Huh.
Okay, so
Looks like it's called a test fixture or something. Or no.
And
No, this is something totally different. Never mind.
evaluate expa running cleanup after evaluate expa and return, but what it does is it returns the value of cleanup.
It
No,
returns the value of
expert.
expert.
And returns the value of expa. Evaluate expa evaluating cleanup after
Returning or after.
It's not after
the
returning.
value of expa is found, or expa or the evaluation of expa is aborted.
Right. Yeah, this feels far too wordy to me. I would say something like evaluate expert ensuring cleanup is evaluated afterwards.
I mean, maybe, it might be kind of technical, but at some level, maybe it's worth specifying that this is to deal with aborts, because otherwise it's kind of unclear why this is different from compound expression.
Oh, but it is. It's actually useful. Think about it. It's actually useful to have something where the value. I'm beginning to wonder whether this name could be generalized, because it's useful, as in I do something, I want to return a value, but let's say here's what I've done. Let's say I've said, x equals 0. X. I mean, it's like x less than, blah, 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 x plus plus, blah, 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 blah. And then I return x squared here. And then I say clean up, clear x. And clear x is not returned, but that's useful.
Right. Like this is a very common case when, for example, anytime I use like open read or something, it's kind of frustrating because you have to use, a module or a with or something like that. Because if you want to close the thing, but then return what you generated before you ran close, you need to make a variable. So it avoids that.
Yes, I think it's more general. I think cleanly is slightly, I think the issue is,
but fundamentally the thing that you're running in the second argument, I think that if you're talking about this as a general, it's the fact that it will run it even if expr is aborted is different though, because if you had a general function that basically just evaluates expr, then evaluates cleanup, and this is but then returns expr, then its behavior you'd want to be different from what cleanly does for aborts.
Why?
Right.
Oh, you mean
because you wouldn't want it to run. You don't necessarily want to run cleanup if expr is aborted, right? If expr is setting up some stuff and then you're running cleanup in your little thing here, but then expr gets aborted, you don't want it to run cleanup.
Okay, let's see what would happen if it was called with cleanup. Then we would say, okay, evaluates. Am I going crazy? Do we say evaluates, or yeah, we say evaluates expr. Running cleanup before returning the result.
Yes, I like that. I mean, I like that description irrespective of the name.
Right. Okay, then we say, okay, so then we would have another one which says, with cleanup, of a init expr cleanup, evaluates expr, evaluates init before evaluating expr, and allows aborts. What should we say here? What does it do with respect to aborts in init?
It blocks them. They will be deferred until expr, and then expr will be aborted.
Okay. Evaluates expr before evaluating.
So you could say something like allowing
running cleanup before returning the result. Running cleanup, even if expr was aborted.
Right.
Evaluates expr before evaluating expr, blocking aborts in both init and cleanup.
Correct.
I kind of prefer with cleanup. Is it troublesome with the with aspect of it?
I don't think so, because you're clearly using with in a different sense, right? The with is clearly being applied to the cleanup as opposed to what's following. So I personally am not troubled by that. I don't know if anybody else is.
Okay, there's a question here from Ethan about asynchronous things. If the expr is an asynchronous task, what does this do?
Well, that's a different. If expr is an asynchronous task, right? I mean,
Or initiates an asynchronous task.
right. Well, that task will,
Go on its
assuming
merry
it,
way.
right, assuming it's not aborted prior to it successfully starting that asynchronous task, that asynchronous task will wander off to its own land, and then the main evaluation will continue, right?
Right,
So,
and finish the cleanup, but it will not clean up the asynchronous task.
correct.
Right, and if you wanted to clean up the asynchronous task, then you'd want to put the with cleanup inside of the asynchronous task.
Exactly.
Nick is commenting that this is the managed monad in Haskell.
Okay.
That's plausible, yeah.
And a with statement in Python. That's really weird.
I mean,
I'm
in
not sure the
Java,
with
you have
statement
the
in-
try. Sorry, you have the try catch finally in Java, right?
Yes. Personally, I'm preferring with cleanup for all of those because that's what this is doing.
Yeah, I'm not sure. I didn't know that with in Python actually will. I thought that I didn't think Python really has anything to deal with aborts. I thought that it just went splat when an exception is thrown.
Emergency
I mean, in the
temporal
sense
shift
that
is
I
asking
don't.
about the utility of separating init and an expr. The reason you want to do that is because you want to block aborts in init.
Right. So, like, if you want to, open a little link to the database, you don't want a half open link. You want either an open or closed link. So you open it uninterruptibly and then you close it uninterruptibly instead of halfway in between.
Right. Okay, I like this. Anybody object? I think this is good.
I do think with cleanup is much better than cleanly, because I cannot think of a precedent of using a command which is just an adverb. So that part I think is.
Yeah, I think with cleanup is very clear. I think it's if you see that in a piece of code, it's very clear what this is,
So my question was going to be, which other functions do we have in which we have an expression, and then if something happens, we evaluate something else? I can think of check, for example, but do we have something else?
There's also like time constrained and lookup do that. But in this case, it's running these no matter what, right? It's always going to run init and cleanup.
Can we just write an example here? With cleanup, so what would be our minimal example? We would say with cleanup, and then we might say, file equals open read, blah, blah, blah. And then we might say open temporary, let's say. And then we would say something like do write file I to infinity. And then we would say
You might want to put a pause in there so that it doesn't first of all, I'm not sure, but you might want to close the file stream before you delete it. And also you might want to put a pause so that it doesn't write 100 megabytes to your disk before you can abort it.
Okay, delete file. You're saying
right. Yeah, you should close it before you delete it.
By the way, I mean, this does suggest that we should have a function that essentially blocks, that creates a file. We've talked about this, a function that says block file, and then it says F. Does that make any sense? And then you do your thing, and then it removes that file at the end.
Maybe. I mean, I think more generally, this is probably a different discussion, but there are some other functions that might be nice for reading files. Like if we had sort of a file fold function and stuff like that, just because they're the main case, at least I run into when it's actually worth using these, open read, open binary read and stuff like that, is when you have a very, very large file. And in a lot of those cases, the whole point of using it is that you don't have to load the entire file at once. But, there's maybe some infrastructure that could be made for making that nicer, but that's a different discussion probably.
Right. Various people are asking, why not just add cleanup as an option to with? We certainly thought about that. The reason we don't want to do that is because it has the 3-argument form, and because with itself has a yet undocumented third argument, which allows one to do.
Well, it's vararg. It's not.
Yeah, it's varargs, right? It allows you to do nested withs. The problem is that we have not yet dealt with the syntax coloring for this element here.
But is there really any connection with
No.
I mean, the name might be misleading in that sense.
It's the name.
Maybe the only reason why the name, why it would actually be semantically relevant is because often for your init, you're setting a variable. But that's the thing about it. And you don't always set a variable in init. You could do something else.
Yeah, it was suggested in the emails, right, that this just be like a third argument for module.
I know, but
that wouldn't. But
it won't work because it doesn't allow you to do the init thing, which you really want. Right. I mean, this is the correct version of the programming thing, because this really, if you don't do the init correctly, you'll be aborting inside the init and you'll spray garbage all over the place.
Right. I wanted to point out your example there, block file. If there were such a function, like that deleted that f no matter what happened during it, that would be the entire reason I use with local settings. But anyway.
Yes, I understand. But that's which is why if this is the pattern, what would this look like? I mean, that would say block file f equals open read or something, or open temporary or whatever it's going to open. And all
maybe it should just be a pure function, the second argument. Like maybe it should just be block file, and then you give it some specification of the file to open, and the second thing is a pure function, and that gets fed the file pointer. And
although
the argument should be the other way around, but yeah.
But this seems like a reasonable thing. I mean, this does some action here. It's like block random, block all these other things. Block file says do a file operation and clean it up at the end. And by the way, you could perfectly well say f equals this, g equals open read, and so on. And its mission is that when it ends, it will clean up all those. Well, okay, so it's got to do two things. It's got to clean up the variables. I see. It's like block in the sense that it defines variables, but in addition to clearing the values of the variables, it's got to close the things that were,
the streams that were opened. But
the R values, basically.
Yes.
To be, I think though that you're right. I mean, the analogous thing is block random though, and I think this is more like block and less like block random.
Fine, but so what's the problem with that?
Here? Well, just that, I mean, it seems like, what you do with block random usually is that, if you're setting variables, you put a block or a module or something around the block random, or the other way around, as opposed to having and then you choose like compound expression and things. And you just sort of freely.
Right, but I mean, so your point is only, but you see, I don't like the idea of having pure functions because I think this is convenient because you could be opening 6 files or something.
No, I'm not even talking about the pure function thing. I'm just saying that, if you go to the documentation for block random, with block random, it's more of a, it's just kind of it says, here's an environment and you can do whatever you want, and we're not gonna tell you here's the place where you do your random stuff and here's the place where you do your evaluation. You just do it. I think that would be kind of the nicer thing for
What do you
block
mean by
file
this?
or whatever.
Yeah,
I mean that you instead of having multiple arguments, where the first argument you're setting a bunch of variables and the second argument you're using the files, you could just have it so that you just open files freely and it keeps track of what's being opened, and at the end it will close them and so on.
Is that realistic?
All right. And what happens if one of the functions you call happens to open
Yeah,
a
that's not
file
gonna
of its
work.
own?
So hold on, are we talking
Well,
about a
you
function
can
that
look
would
at-
close all streams that are open during expr? Because if so, I think
Yes.
that we have functions that do that internally that are bugs. I
Well,
think.
that try to do that.
Right, but see, the point about this is, well, okay, that's a good reason to. The point about this, I think it is not. We don't want a dynamic scoping. We're going to close all files. Assassinate all whatevers in the innards of the internal things of this expert here. But what we do want is, you're opening these files, and you want to close them at the end of this. Okay, so here's a question: how would with cleanup interact with block file?
I mean, I think it would probably could be used in the implementation of block file, just like with local settings could be. But
I see. So your point is that with cleanup would automatically be called by block file.
Yes, I think so. And if you had a block
And-
file inside of a with cleanup, then then
That's
you'll
fine.
have a nested with cleanups that will
So,
hopefully
it could
do
be
the
as
right
simple
thing.
as it's init just checks list of open streams, then it runs expr, and then it checks the open streams again, and could just close the extras, that kind of thing.
So question here: how will with cleanup blocking aborts interact with the cloud aborting computations that take too long? That's a good question. In other words, how will it interact with non-abortable, with absolute? Boy, it just reminds me. In the end, all computing is 40 years old. I mean, I remember from 40 years ago these interrupt levels of computers. Particular computer I used, the level 12 interrupt. The description was the computer is on fire.
kill-10 on most Unix machines.
Right.
If the computer's on fire, do you really care about aborts?
Well, no. That means that it is aborting things. It's doing things like that's an interrupt level. So it's doing things like disk drivers, retracting heads on disks and stuff like that.
I see. Gotcha.
It's nowadays a computer being on fire doesn't last very long. But in those days, it was a big object. In any case, but seriously, that does raise the question of
Right. So well, let me just say that, right? I mean, anytime we expose functionality like this, we cannot prevent people from shooting themselves in the foot, right? I mean, if somebody does pause of 3600 inside of init, then their choices are to wait an hour for the computation to finish or to kill the kernel and try again. Right. That
right. Although the cloud sandbox, for example, will basically kill it because it operates at a higher level.
So I think that the cloud sandbox operates above. Sorry, go ahead.
So it's time constrained if and when we get it fixed.
Wait, you're saying
time constrained? Time constrained will not cause, with cleanup, will ignore time constraints basically inside init and cleanup.
That's true. Sorry, I thought you meant in the second arg.
No. I was talking about the first argument.
Oh, okay. Yes, it will not ignore them there. I mean, yes, it will ignore time constraints there.
Right. I mean, at some level, these issues are already issues you have with abort protect. So I'm not too worried about introducing them.
Okay. So there's a question, I'll be able to modify protected symbols inside a cleanup with it unmodifying back.
It's not block.
Right. So block allows
no,
you
that's
to.
just block. Yeah, go ahead.
Yeah, I was just saying that's just block. And I guess I don't know exactly how block interacts with. I mean, I think there probably are bugs where you interrupt the block, and things don't get completely cleaned up. But generally speaking, right, it should unwind those new values.
Right. Right.
I
So the
think
question-
that may be guaranteed, Itai.
Okay.
Well,
I
sorry.
think I've seen, like, the occasional bug where something gets interrupted at precisely the wrong instant.
Well, there's also, I think if you have a catch throw or something, it might. I'm not sure.
Okay.
Well,
Okay,
catch throws are working the same way as other aborts, so it should be fine. But yeah,
Think
Okay,
so, but yeah, I'm not positive either.
I
think-
would really like to see this block file thing explored. So where should I put this to make sure it's explored? Can you, Evan? Can
I would
you-
also argue that there's several other functions for dealing with file streams that might make sense. But yeah,
Okay. Okay. Well, anyway, for this, Ethan is commenting he wants things to do if the local session, kernel session dies or closes. Yeah, that would be useful, wouldn't it? And that would be a thing that could be done in the front end. But we don't have that, do we? I mean, we had some options for kernel. There's no good reason why we can't have a front end level option that is a thing to do with kernels. It's a good idea. We are revamping the kernel configuration dialog. Could somebody suggest that to Roman?
What is the suggestion?
The
I
suggestion.
think it's so that you can do things like if the kernel dies, run this code, and that code is going to save your file or something like that.
Right.
But the thing is, it has to run. I mean,
It has to start a
obviously
new
it
kernel.
can't run
obviously.
in the actual kernel, right? So I think it has kind of limited use.
Right. I mean, there is an option to automatically restart the kernel if it dies.
Right, but do you even know that it died? How does it know that it's a resurrected kernel? I mean, it's like one of those,
in magically goes back to 1.
that's a hacky reason, but I mean, in
Right. I mean, it won't resume your current
obviously.
operation. It'll go
Right,
to the
I mean,
next input cell.
For me, there are cases like night before last, I was running some computation and actually it crashed my whole computer, which I admit that then I'm out of luck.
Yeah, I don't think there's much we can do for that case.
Right. So, yeah, but if it crashed the kernel and then the front end contained code that would be run as soon as the front end knows that the kernel is, I don't know whether the front end doesn't automatically restart the kernel, does it?
Not by default, although, often, not unless there are like dynamics it needs to resolve or something, right? So
Okay.
there are
Anyway,
situations which will force it, but it won't.
Let's
by
make
default.
this suggestion to Roman when he's revamping this evaluation menu thing. All right, let's continue here. Let's talk about lexical return.
Well, actually, so one other thing, I'm not sure if we want to talk about this now, but there's also after and close or whatever it's going to be called, which is highly related to with cleanup.
Yes, well, we can describe after and close. I mean,
Okay.
do people understand the enclose confirm? Is it runnable? Oh, it's not runnable because 12.2 is crashing.
Not familiar to me.
Yeah. Okay. Well,
Okay,
if you
so-
have an older version of 12.2, you can run needs of error handling, and then it's running.
Well, Danny's on Linux, so he doesn't have the constant crashes. That was a Mac
I
only
have
issue.
my share.
Yes, but you don't have the moment you click in the notebook, it crashes bug.
Not
going
too
to-
often.
Oh, that one is still crashing too.
Oh,
Right.
okay.
Okay, well, anyway. So, Christopher, do you want to demo it for a second, or should I describe it? Or what?
I guess I can quickly demo. And close confirm stuff. Just a second.
Okay.
Yeah. I mean, just so that people know. So I mean, basically, this is. Let me see here. So these are just these error handling functions. So the basic thing is there's a function called enclose. I don't even know what version I'm in, but I think this will work. And essentially, you can have whatever code you want here. Let me just write some some random thing. And what happens is that will just evaluate the code and return what's at the end of it. But you can also have these functions confirm, and what confirm does is confirm basically is the identity function if you feed it something nice. So for example, if it's just going to be 8, it will just evaluate it and it will run the echo and everything is happy. But if it's something that, some sort of failure like thing, then it'll abort, it'll stop everything, and it'll return a failure object. Now there are several different types of confirm, so it's not just looking for $failed, and there's confirm match and confirm by and confirm quiet and so on. And there's various things about processing this failure object and so on. But this is the basic idea.
Message? Why is that the message? $failed is.
This message is actually different in a newer version.
Is this a specialized form of catch throw?
Yes.
It is effectively a specialized form of catch throw, although it has some different properties but unless you give it a tag, it's lexical, unlike catch and throw, which are not lexical.
Okay. And also it doesn't always do the analog of throw that's only for certain conditions. The confirm case, I guess.
Right. So it'll only throw in certain conditions. Yeah.
Okay.
The typical thing is that you just write enclose around a big block of code, and then you write confirm around something that might go wrong. Make that a table or something. Make that the
yes. Yeah, so, I think this is often a common case. Is like, if I have x of an integer, it's going to be x plus 1, and then if I have x of f of something else, it's going to be $failed. This is and then if I want to call f, if I'm going to do something, I want to call f of 5 plus 6 over 4, but I'd want to make sure that f is going to return something sensible, right? So maybe I'll define a g like this, right? Now if I run g of 5, it will work, and if I run g of if I run g of not an integer, then it will fail more gracefully than it might otherwise.
I see. Okay, got it.
So right, and again, there are different confirms for detect. I mean, the generic confirm only detects the most blatant errors, but there are other types of confirm for detecting more complicated types.
Like for example, confirm match. You can say confirm match of expression comma. Well, actually, confirm by expression comma numeric q would be a common one.
Sure. Right.
So
okay.
Exception handling that of a much better sort than currently.
Yes.
Yeah.
Right. And the trickiness, the cleverness here is the fact that this is lexical. So in other words, that confirm is having tags written into it that
well, basically it's just there's two things. So one, you can make it non-lexical if you specify a tag, but the basic thing is that throw and catch are often used to do things like this, but you have to be kind of careful because first of all, if you don't give a tag, there's a lot of dangerous stuff that can come up with user throws getting caught by your error handling catch and so on.
Yes.
And then even if you do have a tag, right, and so you kind of, to avoid that, making it lexical means that it's just you don't have to write a tag, and it basically does what you're doing 90% of the time anyway. So, right.
For people who are asking about check and message, we just can't do it given the syntax.
Sorry, what about?
No, somebody was asking. Ethan was asking about whether this could be done with check and message. It cannot, but we can. There's a confirm message that says if a message was generated.
From quiet, yeah.
Oh, okay. Confirm quiet.
Yeah.
So then what is? So then that will be if you'd say 1/0 there. Why did it do that?
I'm not. This is maybe because it's an older version. I have no idea how encloses even exists in this kernel, but I don't know. I'll have to look in a second to see why it's like that. But right. So the point is that what we're talking about now is after enclose, where the idea is right. So the point is that this is essentially an abort that can get run, and so the idea is that maybe there should be something called after enclose, where you can provide cleanup for if the enclose gets either if the enclose gets aborted or whenever the enclose finishes, it should run this cleanup.
Why isn't this an option to enclose?
Well, for two reasons. The first thing is that it depends on how far it gets, what stuff you want to, run. So for example, if I had enclose of, f equals open,
Second
open
question,
read
what does
of,
after enclose return?
I think it should just be an identity, well, after enclose probably returns null.
Maybe after
because it
enclose
doesn't do anything.
returns the symbolic form with the thing unevaluated.
Like a hold? That's
the whole thing.
maybe.
It just returns unevaluated. Because it's only activated if enclose fires.
Well, no. It's always going to be activated. It's always going to be run eventually, right? Because imagine this case here, right? So in this case, what you want to happen is, okay, it's running here, and then, oh, there was a confirm that failed at this point here. You want it to close F.
Yep.
Another version is you run it, and then there's an enclose that triggers here. You want to enclose both F and G.
Yep.
Or it just runs all the way through and finishes. You want it to close F and G. So there are several. It depends on how far it gets.
So it only the after encloses that you have gotten to are added to the queue. That's
Right.
basically what you're saying. So
right.
each
and
one
I
of
think
these.
Also, yeah, go ahead.
Yeah. So implementationally, after enclose will look, basically say, oh, am I inside of an enclose? Let me register this command with my nearest enclose, and then whenever that enclose finishes, it runs all of those guys.
Right, and I'm guessing it should probably. So there's a similar construct actually in Go, and it has a nice feature which is that it runs them in reverse order. So that is, it's like a stack. It adds them to the stack and then it pops them back out. So I think that's also probably what it should do. So it will close G and then it will close F. So it kind of unwinds everything.
Right.
Implementationally, you could just make it a with cleanup, and the cleanup is run the functions that are this variable, and then you just during enclose append your functions to that variable. Like so.
Almost. I mean, it's almost that, but I think it's actually doesn't quite work. Partly because I think that arguably this should only work with confirms and not just arbitrary aborts. And then the other thing is that I think you could also do it with so and reap, but right. I mean, there is a question of what happens if there's a generic abort, because normally enclose only really, it's only catching aborts that are thrown by confirm. If I run return or if I run abort or throw, that goes straight through the enclose. And so arguably after enclose should also not, it should only be looking at confirms.
It should only look at confirms. If we want an after abort, which we could have, no, it would be after abort protect. It couldn't be after abort. It would be after abort protect, I think.
Well, with cleanly is to some extent doing that.
With cleanup.
Well, but after abort protect is literally just abort. You can do that by just doing abort protect and then writing something afterward. So
yeah.
Right. Anyway, I think after enclose, from what you're describing, I think after enclose, arguably what it should return is itself with its tag filled in. Doesn't it have a tag that associates?
Well, right. So it'll also need, it probably needs an optional second argument, which is the tag of the enclose, if the enclose has a tag.
I see.
Right.
Because otherwise it'll unwind to the nearest lexical enclose.
Yes.
Correct. So even if I said
yes.
even if I said G of after enclose, it will still unwind to the nearest lexical enclose, like a confirm would.
Yes, I think it should be analogous to confirm like that.
Right.
I think it's one way of thinking about it is it's analogous to confirm, but it's like after enclose is to enclose as, or after enclose is to confirm as so is to throw. I think is arguably what this is.
All right, so here's something I don't understand about the semantics. Suppose between the after and close of F and the G equals open right, I do like throw of $failed or something. maybe that,
Whoa.
or even abort bracket.
Right.
Then
Then the after enclose doesn't run. It's just you boom, you're out of there.
Right, because I think that enclose right now, enclose doesn't do any generic abort protecting stuff. It's just catching confirms. I think that's probably the right thing. I mean, maybe
if the user wants to wrap abort protect around, they can do that.
Right.
But it's not implicitly enforced unless, it has to be explicitly there.
What is happening with your line breaking, Christopher? Did you set some
I was just wondering that. I don't think I've said anything different. I have no idea why it's doing that.
I think it's because of the dot dot dots.
Yeah, that's likely.
If you use XXXs instead, I suspect your line breaking goes back to normal.
Who knows? Okay.
No, it's mysterious. Okay.
I mean, but maybe actually, I forget you said this earlier. Maybe actually then in this case, it might make sense to have some, not the right name, right? Because what if you wanted to deal with this case, right? Where critically you care about how far it got. I mean, I guess you could do that. The way you do that right now is you do this, right? And then in the middle of it, you'll write, so of something you want to run, and then at the end you'll have to pull out the reap, and then you'll have to run the things and so on. But
let's
maybe there
cross
could be a
the
function that does
enclose
that.
confirm bridge first. We'll worry about raw aborts later.
Okay. Well, so I guess then the other question is the name after enclose.
Seems pretty clear to me.
There
Anybody
is
else got comments on?
related issue, Christopher, you brought it up, but it's a general one, which is return with 1 or 0 arguments is going to
That's the next topic on our agenda was lexical return.
So
we need to, but we're going to need to actually do some changes to the existing return if we want to correctly handle with cleanup.
Really?
Well, no,
Yeah,
I think normal return is just an abort, isn't it?
No, that's the problem. The aborts with local settings handles aborts, but the 0 and 1 argument returns exist in a different universe. And it's not exactly parallel or perpendicular, or it probably.
Can we talk about lexical return for a minute and then come back to that?
Okay.
Can I just make one point about after encloses? One possibility would be is enclose cleanup, but then that would suggest that with cleanup is not, that would suggest that with cleanup is associated with, which is not.
Yeah, right.
Right. So that just gives me a bit of pause about with cleanup.
Yeah, I think after enclose is better than the things with cleanup in them.
Enclosure cleanup. I mean, we'll be thinking chickens or something here.
Yes.
Let's continue for a moment and poke at the lexical return issue.
Okay.
Am I getting the screen back? Okay, fine.
I think so.
Okay. I mean, the basic idea, the thing pioneered with enclose confirm is the idea of lexical if you don't specify a tag, dynamic if you specify a tag, right? People understand. Danny, you might not have understood that point. That the fact that you can just say enclose confirm, which is what people will do 99.9% of the time, is a consequence of the fact that a tag got inserted automatically and lexically. But if you wanted to, what's that?
I got that. I heard that.
Right. Okay. So I mean, if you nested a confirm deep inside your code with a tag, you could have it worm its way out just like a block. Am I making sense? So the question is, could we make a lexical return which does the most obvious thing, which is you've got f of x blank colon equals blah, 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 and there's a return right there lexically. And it returns from the down value evaluation, if you understand what I'm saying.
Well, so
I
how
got
is this?
lost somewhere in that sentence.
Okay. So we've got f of x blank colon equals do blah 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 semicolon lexical return. Okay. So my point here is that then what that would do is, if that is lexically visible in the f, in the definition of f, then it will return to the top level. It will return, this lexical return means whatever block of code was here in this R value, the value of that is to be the value of the return.
So is it not just, okay, is it not basically the same as return, but it just ignores things like do?
That's what it is, I think. Yes, it is a return, but it is only, I don't know what return does. Does return have dynamic capabilities? If I have something where I have an F and a G, I guess it never goes through the boundary of the inner G. I don't understand the semantics of return. I have not understood it in 30 years. I mean, I think it's a, I mean, arguably, oh boy, it has such a short.
It's on the top 5 list for misdesigned functions or functionality. Nobody really understands it. You get these returns inside of you get things that are encapsulated in return or not, depending.
The undocumented 2-argument form is quite useful.
The undocumented 2-argument form.
I never even know about it. What's that?
It's the only form that's actually safe. It's the one that uses the abort system signaling, and it can be made to work safely without exceptions.
This thing is a horrible mess.
That would describe it aptly.
Right. So the question is, how do we fix that?
Right. So I mean, the 2-argument form takes the expression and the function to return to. So it will you know.
Oh yeah,
always,
yes.
So you always know what you're actually returning from.
Right. So this would be something which lexically fills that in and forces it to do that return.
So it will only ever work on the right-hand side of a set or set delayed.
Exactly. Yes, it will not work.
And friends.
So I mean, this is really, though, this basically just sounds like it's a more pure, because look, return at some level, you know, return in many languages is this, where it only ever returns from functions. I know. And then this return is kind of, is a bit naughty in that it, you know, it also returns from other things like do and stuff like that. And so basically what we're talking about is just a more pure version of the existing return that just only does functions, essentially.
So what exactly is it returning from? It's not returning from compound statement, obviously, because that's inside the do.
It's returning to the thing, which is, if you look on the stack, there's an F call, and then there's something inside the F call, right? This unwinds the stack to the point where it's looking at the F call, and it returns to that.
So set delay sees the lexical
return translates into our internal code.
I mean, I don't understand why this is different from return, other than the fact that it ignores. I mean, maybe this is just, maybe the correct implementation is just the existing somewhat crazy implementation of return, except it just ignores things like do and while.
No, Christopher, you might be absolutely right. I'm just not sure.
Yeah.
Anyway, I think function return is a possible name. We have these various comments on our live stream about, Nick is commenting on, what about a construct like with F equals managed open read? It's an interesting kind of construct. But you see, this is going to get the same stupid problem as return. It's the same. We don't want to make the same mistake 30 years later, 33 years later. That is, what is the scope of managed? Do you see what I'm saying? In this case, I mean, if it's a scoping construct, go ahead.
And how do we know what it actually wants to do with, you know?
Right. I mean, it could have a cleanup thing here, but then we've got, then we're back in the same story as lots of other stuff. Then it's got to refer to that, and it's got to be a function that does that, and so on and so on and so on. And the question from Ethan is, why not a general cleanup option? Again, I don't think it's going to work because I think these functions all have their own localization constructs and so on. I think it's much better to have something which is a general wrapper, just says with cleanup and thing, comma, cleanup. It seems pretty clean, not to make a pun to me. But anyway, so look, I think this function return idea, if we can explore it, it will be good. The question is, can we make something which is, it just is returning from the function. It doesn't return from, it returns. Does that make sense to people what that's doing? And yes, it could be that that is implementable just using return without some of its lunacies. The problem is we really wanted return to be a functional programming construct, but then we have these plainly not functional programming iteration constructs, and it was not unclear what to do. I mean, that's the only excuse for the mistake. Yeah, revamping message. We know. Message needs to be revamped.
Right.
One irony is I think some of that loop breaking and returning could have been done with a better designed break.
Yes, I agree. I mean, is break as broken as...
Right, so break only takes a 0 argument form, right?
That's the problem. It is not as broken. It works in the correct signaling framework, but it doesn't allow for returning a value.
Why don't we give it a one argument form that returns a value? Try over the course of a very long period of time to phase out return. I mean, why on earth does break not return it? That is kind of stupid. Why does break not return a value?
Well, because the things that it works in, certainly the documented things it works in don't return values, presumably.
Does break work?
Yeah, that's the point.
What does it work in? Does it only work in?
I think do, scan, map, maybe.
I mean, things that don't return values are pretty ugly in the world of functional programming.
Right.
Sorry, not scan. I think it doesn't it work with scan, or is that just return?
On the message for when you don't put an enclosing thing, it says it's for, while, and do. But that message may not be
right.
I don't know if that's everything.
Yeah,
we should take a look at break as well.
Mm-hmm.
Yeah, but Itai's got a point. These things don't return values anyway. So,
what about continue? The heck does that do? I mean, I never use
like a standard.
It goes to the next loop.
C function, yeah.
Well, I know that. I know that. I mean, it was put in to emulate what people expected from languages like C. But how far does it go out? Does it throw out to the nearest enclosing?
Well, look, it throws out. It probably does that.
Yeah.
Yeah. Same thing as break. Do, for, and while.
Yeah, I'm pretty sure these are implemented appropriately, although I'm not positive that break is limited to those three. I'd have to look at the code.
Okay. Let's have a very quick look at this symbolic pointers thing, which we're unlikely to be able to resolve quickly, but that's why our chemistry team is here. They, horrifyingly, want to have...
Right. So this
is advanced since the...
Not really. I mean, I guess I had a meeting with Jason to sort of bring me up to speed on what they're trying to do, and which is sort of the middle point is what they want. But I am not a fan of this because, for one thing, right, you couldn't type in these atoms, right? It's basically working
Which
using...
kind of atom are we talking about here? We're doing chemistry. What kind of atom are we talking about?
Atom, open bracket, C, string C, close bracket.
We're talking about chemical atoms.
Chemical atoms, not atom
Yes.
Q.
Yes.
Okay.
Very confusing, especially when you talk symbolic pointers.
Okay, well, let's be clear.
Right,
okay, the issue is, explain the problem that you're trying to solve, Jason.
Right. So it would be nice if there was some function that could wrap an expression and turn an expression into a pointer that could be dereferenced. So that is in the prototype right now. I mean, So
Okay, why do you want that?
Right. So it's the middle point that I make right there, that not all carbon atoms would be. It's right there in the middle bullet point in the agenda.
I know, but I don't understand.
Right. So
essentially,
not all carbon atoms would be the same, but some carbon atoms would be more equal than others because they would be associated with particular molecules. So you could just do atom of molecule property.
Oh boy. So in other words, this is basically asking for an expression which would otherwise be a shared expression, like a string or a number. The number 3, this could be a 3 with some particular property or provenance associated with it. Is that
exactly
what you're asking for?
Exactly. And that's what I think is crazy.
It's an unbelievably huge, that would be like saying, let's add properties to every expression, including raw ones. And by the way, that particular idea, I honestly haven't thought about it in 35 years, but the last time I thought very seriously about that idea, it has one of these ridiculous sliding slope into insanity, because you have properties of properties, et cetera, et cetera, et cetera. The fundamental problem, let's recall, the fundamental problem that Jason is trying to solve is he wants his carbon atom to have a tag.
Right.
Of some kind.
To know what molecule it came from.
Why do you want that, Jason?
Let's see. So
he doesn't like typing molecule value.
Read, and it makes them easier to use. So it makes code to iterate through atoms. It makes writing code using these atoms more useful.
Okay.
So
the goal here, listen, just to explain, the goal here is to figure out how to achieve what you think you're achieving with this mechanism that I think is undoable without having to have this mechanism, but to achieve whatever you're trying to achieve. So can you explain what you're trying to achieve? Do you have an example? Do you want to just show an example?
Well, you can open the thread and the email thread, and there's sort of an example there. Right, so he has a molecule of propane, and then the key sort of example is in a 43, right, where he's extracting properties of the molecule by, doing a subvalue of this atom expression, even though all 3 atom expressions are same Q to each other because they're all.
Why does he want to do this? Why do you want to? Okay, this is crazy, but why do you want to do it? Why is it? Why do you want to have the carbons independent of the molecule?
Let's see. So without doing it, without treating the atom as its own object with its own environment, that then you have to constantly keep track of the index, the position that it lives at, and so all of the code that you write has to keep track of the index. And then when
which code? Which code? So for example,
the code that I write or the users would write when looking at
like for example, this piece of code, this topological steric effect index, which I don't know what it is, but that piece of code, you're talking about that piece of code there.
No, so that piece of code is very easy to write other ways.
Is the issue that the problem is that by keeping track of the index and so on, you basically mean that instead of atom of quote C, what you would have to have is something like atom of quotes, where basically it has the molecule and then it says you're atom number 7 in this molecule, and it happens to be a carbon and it has certain properties and so on. And
right. So every function I write has to take an argument, the molecule and the atom index, rather than just taking the atom.
Okay.
Why you could just have the atom? Maybe there's a problem with this, but it seems like you could just have it so that atom head has maybe an optional second argument or something like that, where it specifies the kind of the context for the atom, like the molecule and so on.
But it's got to have the part number in the molecule. So it's got to have both
it just has to specify the molecule and where you are in it.
Right, and so I guess ideally then you just put in a cheap little reference to the molecule in part is what I'm.
But you don't need that. You don't need
what's different between just having the actual, why not just have something with head molecule? Why is it important that it be?
Because remember, in the actual internal implementation, it is the same piece of memory. If you just have that molecule thing there, the only thing that's special is that part specification. So the molecule here is some giant molecule of blah, 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 whatever it is. And, that might be a huge thing. It might be a giant protein, right? But it doesn't matter because it's the same piece of memory.
But not when the user then reevaluates it. If
Yes, it is.
the molecule expression lives inside that atom.
No, you're wrong. You're wrong. You're wrong.
Well, no. Well, if you correctly hash your molecules, then the molecule is still in scope, then it will, go to the same one. But you're right that it won't parse to the same molecule.
Right? No. If you serialize and you read it back in again, then you have a different issue. Right? That's the case.
No. Right. If he types in molecule of, right, if he writes mol equals molecule of blah, 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 then obviously that's going to be the same molecule.
Right.
But if he types in molecule of blah, blah, blah in that
exactly, then it is different.
Right. So,
if it is being typed in after it has been serialized.
Right. So if I return to you a list of atoms with the molecule in there, and you just use it as L values, like referencing that list, then you're right. Absolutely, it is the same piece of memory. Let's see. I guess I sent this email because I think this is kind of a neat thing that can be done with undocumented top-level Wolfram language code, and I rather like it. But everybody I've shown it to dislikes it, and I sent it to this email, and it seems as though that is still the case. I think maybe there could be a.
Hold on, Jason. We're trying to solve. You invented this because you have a need to use it for some particular purpose, and what we're trying to do is to figure out how to achieve that purpose without doing something which is going to be a design insanity. Right.
So I wonder if he
more clearly.
I wonder if what he really needs is some sort of data structure, right? That could go into second.
I was going to say the same. The compiler people have data structures, including trees, I believe.
Well, but actually, I was going to say, I've been waiting to say this, but I mean, in the compiler project, they have actual references, as in there's a function called create reference that makes basically a mutable expression. But I think that's also something that I don't think necessarily should be spread anywhere outside the compiler project.
No,
okay, but
that's what's used in the data structures.
Right, let me just summarize what I think Jason's issue is. Okay, I think it is an issue about serialization. I think the issue is if the molecule thing here, there's two issues. One is the convenience of having an atom that you can just think of it as an atom and it happens to carry along its molecule. Okay, I think you can deal with that. There's the issue of what if this, it's crazy if your molecule contains a bunch of atoms, which again then contain the molecule, right? That's crazy, and I don't even know how that ends. I mean, that just recurses forever. It's a circular data structure, right? So that is a non-workable thing.
Right, but maybe you can have a representation of atom, inside the molecule. It'll say, here's the list of atoms. When you're specifying the molecule, you'll say, I have this atom, and it'll be atom of quotes C, and I have this atom, and it's atom of quotes H, and so on, right? But then when you say atom list, then what it does, instead of returning the actual representation of atoms that are used inside the molecule, it could return something where it says, oh, this is atom of, this molecule, arrow 5 or something. I don't know.
So someplace where we do something kind of sort of similar is cell objects, right? If you do cells bracket, it'll give you a bunch of pointers to the individual cells in your notebook.
Which is fairly horrifying.
Right. But you can then, but then you can manipulate those things, right? And if they
no, that's utterly horrifying. Look at that. I mean, that's a creature from the early 1990s.
No, it's not.
Really?
It's a creature from about, 4 or 5 years ago. But that's a pointer to the actual cell there. So if you were to save those cell objects somewhere, but then close the notebook, it would know that those are no longer valid things.
Without those being UUIDs?
Yes, because I mean that's like the MathLink index or something or other. I mean they will start using UUIDs in the future version that's on the to-do list now that we have UUIDs, and that will make them sort of more persistent. But of course, if the notebook is closed, then the front end won't know how to resolve that UUID because it's not going to scan your hard disk.
It doesn't know how to resolve the UUID.
It seems though like stuff like this, where basically the full form is not the whole story. I think this is something that's like to be avoided though. I mean, maybe there are cases where you kind of need to have it. Like I mean, there are cases where you need to have it. For example, like I think you sort of have some things kind of vaguely like this with nearest function and other functions like that, where there's secretly some C data structure behind it, but that obviously can't be
right. But even in those cases, there's enough data in the full form to reconstruct the data.
Exactly, right. And I think that maybe there, in the case of the cells, maybe
right.
Really
I mean, the cells is sort of necessary because otherwise, right, all the attached cells that we have would not work if we couldn't ask, find me my nearest enclosing cell and give me. But
so hold on. So one thing is pure efficiency. That is like rule, for example, has a hidden third argument, has had for 30 years, right? It's purely used for efficiency.
It doesn't anymore, actually.
Really?
Mark removed it 3-4 years ago, I think.
Oh, it's using weak hashing of some kind instead?
Probably. I don't remember the details.
Okay, fine. All right. Well, that's a shame. My story explodes then. But seriously, there are plenty of places where we have internal efficiency forms, some of which are serializable. If I understand what Jason is trying to do, he wants to iterate over atoms, okay, knowing what molecule they're in. What is the exact operation you're trying to do on these atoms?
So I would love to return an atom iterator, something that could tell you all the properties of its atom, and then would have a next method.
Well, that seems a much. What about a molecule map? Molecule map, which maps over the atoms in a molecule.
So to map a function, right?
Yep. Over molecules, over atoms in a molecule. I mean, is that useful? I mean, because it sounds like that's the type of operation you're really trying to do.
So I can definitely explore that. That does sound useful. So I actually I brought this forward. I guess because I rather like the weak hashes and the expression references. So I might have
no, but listen. The only thing that people are dumping on here is the following thing. Okay. Is the what you see is not what you have story. That is, if you've got, every carbon atom in the universe, so far as we know, at least every proton in the universe, so far as we know, apart from its spin direction, is identical. Its momentum and its spin, all these protons are identical. We are in the process of violating that idea by basically attaching random gunk to these protons, which is sort of an anti, right? But and that's the part that doesn't seem right. A proton is a proton, and that's all there is to it.
It's not even that. It's not even that. It's that the full form is. I think the issue is more that the full form is not the full story. Like that, there's hidden stuff that's not in the full form.
Right, but so I might also though propose that we someday have an exposed weak hash table, right? That it was like treasure when I found it in the bowels of.
Well, that is an interesting suggestion, right? That's an interesting.
And if it were exposed, then this idea wouldn't be so foreign.
But I think there is a difference, Jason. With a weak hash table, what you want to do is to avoid repeating computations. But it's information that you could get from the information here, from the information you have. While what you want to do here is to attach information that is not available in the thing you see. That's the part we complain about.
Yeah. I mean, So I use the weak hash table for the molecule, and I use it the right way, with all the
which is fine. Nobody has any problem. But look, I think the right solution is some functional programming thing. Look, functional programming meets chemistry. What operation do you really want to do what is the operation you're actually trying to do as you iterate over atoms? What is a typical operation?
So I mean, you search for ones that have the right environment. You check the number of their valence, their charge.
So do you typically
you get their neighbors, right? You
Right.
count the
So-
neighbors, these kind of things.
Okay, so in other words, and how would you do that normally? Given a molecule, you refer. How would you get, given an atom in a molecule? How do you find its neighbors? If I just get a random molecule here.
Well, I guess the first question is how do you have to specify which atom? So I guess there's like an atom index or something that you would give.
Right. So you access everything about the atom through through either atom list or molecule value, and you
Right. But so the issue is that the mistake here is once you've extracted the atom list, okay, you no longer have, this is the mistake. This is the mistake. This is,
Right.
look.
The atoms don't have any information about where they are.
Which is why
Right,
you
they
have to
don't
use a
have the atom
3-argument
index.
form. You use atom list of the percent, then all, and then say, I don't think neighbors list actually is a property, although it should.
Right.
be.
But what
So
you,
what, I mean,
go ahead.
Right. I mean, the atom list could have returned an ordered pair of atom, comma, position or something.
right, or better yet, I mean, there's this head atom, and that head atom could have more in it than just quotes C. It could have, it could have basically the molecule and an index, and it's basically just saying I'm the third, atom in that molecule, and then you could just map over that, and it knows where it is in the molecule and everything.
What do I do to get the second?
You want a 264. Not that was your type mistake. It's 264.
But that still doesn't give me any
No,
additional.
but the third
So
argument.
then the third argument
argument.
is where you put in properties.
What property do I put in? Can I put in a position here?
So let's see. So at this point, you would this like the string formal charge, right?
But that's not what I want. I want to know which atom. I don't know which hydrogen atom is that atom. See what I'm saying?
Atom index would be the.
I see.
And then the list atom index some other property.
Well,
So
can I get
that is the current way to get these types of properties, right?
So sorry, I mean, not to repeat this too many times, but why is atom not just a molecule, comma, an atom index? Why is it just a string? I mean, it makes sense for some cases for why it would be just a string, but in this case, from atom list, why doesn't it have this different form? Or why couldn't it?
So of putting the molecule expression into the atom expression.
Yes.
Which,
Right.
I guess bulk at the, I mean, so I know we're just serializing to the notebook and sometimes not even, and if we're not serializing to the notebook, then there is no memory increase is the point that is being made here.
Yes. Look, listen, Jason, I think we should wrap up here, but look, I think the basic bottom line here is there's probably some really interesting functional programming. I mean, the basic problem that you have is once you've got out the atoms, you don't know where they came from. But you have functions that want to look around at the environment. They want to do things while looking around at the environment of the atom, right? So it's similar to, I mean, map, for example, also is location independent. It just does what it does. All it knows is the subtree, right? Map indexed, on the other hand, knows where it is, right? So what you need is an analog of map indexed where for a given atom that you...
Well, I'm not sure he even needs that. I mean, just like a molecule map, as long as it has the molecule, it has the context, right?
No, but it doesn't know. It doesn't have the context. It just knows molecule
sure it does.
No, it doesn't have enough of the context. Go ahead.
I think that the issue here, I mean, first thing is I think that you could have a molecule map, but I think it's kind of messy and it's going to be this thing where you have molecule map and you have molecule select and you have molecule whatever you have. And it would be much nicer if you don't have to introduce the whole set of sort of functional programming constructs with the word molecule in front of them. Right?
Yes.
And also I know the issue you're about to point out, I think, is, or that you were just saying, is the issue that it is kind of more like map indexed, because what is the hash that gets fed to the function? If the hash is still just atom of quote C, it doesn't have that context. So again, I think it comes back to that you need to have some representation of an atom where it's an atom in a molecule, where the representation is not just quote C, but it's a molecule and then a position in the molecule.
I think so too. But now,
what's
what's an interesting point is that for expressions, in all these years, we have rarely needed that. That is, in something like, going up the tree, right? Map just looks down the tree, right? Asking the question, oh, I have this function f, but it only wants to apply in places where this or that structure exists, right? That's the kind of thing you'd like to do. You'd like to say, I want to look only at carbon atoms for which this, that are in this stereochemical, environment, such and such, right? You want to say, take all the carbon atoms that are in this stereochemical environment and tell me what their formal charge is, or something like that. Is that right, Jason?
Yes. And so for there's actually a fairly decent way to do that. So the second argument of atomless there can be a pattern that matches a single atom. And then with the third argument being properties.
So that second argument gives you what? Gives you the fragment of molecule around the atom? What happens if you want to say all atoms connected by double bonds? Somebody's typing very loudly.
Right. So all atoms that are part of a double bond, you can write a pattern for that. For a you would use a Smarts pattern.
Okay, well, this is a further discussion. I think it's a really interesting point. How do we do mapping over molecules knowing their environments? Because I think that's the right solution. What you are describing is, and we've almost done this a zillion times, is things like object-oriented graphics, where you can pick up a circle and the circle knows that it lives in this hierarchy in this place, right?
Right. I mean,
and every time we get close to doing that, we realize it doesn't make sense. And I claim this is going to be the same way. But we do need to think about how to do what you're trying to do. All right, we should wrap this meeting up. That's funny. Somebody I see on the live stream is commenting that using the resource function time to read computes that to read the NKS book is 32.5 hours. Well, that's a good way for me to spend a couple of weeks. Okay. All right. Okay. To be continued, guys. Anything else here? I hope not. We're way over time. All right. See you guys later. Thanks. Thanks.